And it is recording. All right. So this is our last unit that we have for the year. It is basically using all of the functions we've already learned and applying it to real-world situations. So I think I mentioned before, I have a friend who knits. She knits as her business. She was trying to start a knitting business. So she makes these little figurines that are really ornate, really good. But it takes her like 10 hours to make a little figurine. So reasonably, how much does she have to sell that for in order to sustain herself? $100. So if it takes 10 hours, that'd be $10 an hour she's charging for her work. $10 an hour isn't enough to make a full, living, right? So she could have done the math behind it and found right off the bat that she wasn't going to be able to make what she needs to sustain it, and maybe found a different business model, found people to help, or maybe there's different things you could do. But you don't want to go into a business endeavor without having done this out. Everything that we are going to work on today and tomorrow is about real-world situations that if you go into business or if you take any business classes, the math is going to be related to things just like this. You're relating one variable as a line, you're relating the other as a line, and where they intersect is important information. That's where you'll shoot for as your target. Okay. The intersection is always going to be our key data. But we have these already. We have linear, quadratic, and exponential. And I want to ask you first, I'll ask you this question. If I have 2 points, what can I make?
Line.
A line. Okay. Could theoretically I make a parabola?
Yes.
But will I be accurate?
No.
No. Because what parabola could fit here? I could fit this one, right? I could fit this one. I could fit, this one, right? 2 points isn't enough for us to use our quadratics. 2 points is enough for us to use linear. You agree? 2 points for linear. If we have 3 points, then what? Now what can we make with some certainty? A triangle. Or, these are ugly, horrible drawings. You need some better ink. 1 second. Pause, intermission, talk amongst yourself. Here's the topic. And we're back. All right, so I have 3 points. I can make a parabola. So in that case, I would use a quadratic. So just looking at the piece of information, it's the first step because it tells you what kind of model are you creating. Are you making a linear model, a quadratic model, or an exponential model? All right, so let's look at first off. Example 2, we know we're going to use a quadratic because we have 3 points, 1, 2, 3 points. So we know that we can make a quadratic, we can make a parabola. Okay. Over here, though, this one is very straightforward. This one we're going to be using the linear equation. And I want you to think about what might go into each of these places. Let's read it. To print a logo on a phone case. Vistaprint charges $750 for the design fee. So they pay for, that component. Charges a $750 design fee and a $3 per phone case and $3 per phone case. That is Jackson. And $3 per phone case. How many phone cases can you buy for $1,200? Who is like an officer of a club? Officer of a club on campus? Okay. So, it's time at the end to buy t-shirts. You have a budget. This is something you would actually do. If you didn't know how to do this, you're like, I don't know, let's get 50, right? It might cost way too much, and you may not need 50. All right, guys. So, this happens a lot, just little business decisions. You don't want to overbuy or underbuy things, okay? Because it costs a lot to get some extra. It costs too much if you're buying too much. So let's look at y is equal to mx plus b. Y is going to be my outcome, how much it is total. So let's go ahead, and I'm going to let you actually try it. I want you to try to put the data from example 1 into a linear equation. What goes where, do you think? What goes where? You can talk with your neighbor on this. Let's bring it back in 20 seconds. All right, if you're not talking to your neighbor, talk to him.
Vegas can't be too new.
All right, what is the cost that's going to be a part of the total charge, no matter what? What's the cost we have to pay? $750. All right. What is the total that we're going to pay that is our budget? $1,200. Okay. How much does each phone cost? So based on how many phones you buy, 3 times that amount, plus the $750, that has to add up to our total of $1,200. Who had this equation right here, like so? Feeling good about it? Find that, right? The constant, the y-intercept is really where you're starting. So if we were graphing this, we would start here at 750, and we're going to have some kind of, up 3 over 1. So actually, it's going to be some graph like this. You would then go and look and see how many units you would need at 1,200, and where it intersects would be our total value. So tomorrow we're going to learn how to get this graphically. But now I want you to just solve for x. How many t-shirts should we get? Or how many, phone cases? Let's subtract this. So we get 450 is equal to 3x. X is 150 cases. Yeah. Yes. So you see, it seems really basic, but you want to be the one on your team that knows how to do this. And you'll learn it and read, if you're going to be in business, you'll see some things much more complex than this, but this is just like a basic. For your clubs, don't buy too many shirts. Do this out. See how much it costs with your budget. Okay. So the goal is, just like the art of war, it says you can know before the battle has started who's going to win by looking at all the little assessments. Read that if you haven't yet. I feel like over my life, that's one of the most important books for strategy. Yeah.
But you're not accounting for team morale or positivity.
That's like the 7th chapter in his book. He's talking about just that stuff.
Well, you can't calculate how excited you are.
Yeah, you can. Well, here's the thing. He's saying, does this group of soldiers have better discipline from the higher ups than this group? So when there's 2 forces, it's just like which is more or less. You're right. Things are hard to quantify with 100,000 troops. Right. But you can see, and you can send in spies. That's chapter 2, spies.
Also, whoever has more food is probably going to be more happy.
It's true.
That's just a general.
And Sun Tzu breaks down even the cost for how much it'll cost the country to send in groups. So he's saying, don't bring in all your food. Pillage the villages there because it costs 3 times as much to bring from your kingdom. All these ideas, and not think of it as defeating an enemy. Think of it as overcoming anything. It's really, you can, especially into business, there's a lot of books relating art of war to business. And I'll keep going now. We have 3 points. I want you to divide it into 3 parts. We're going to have 1, 2, and 3. We're going to continually find clues to end up at the end inputting information for our A, our B, and our C. Okay. So let's start with our first point. We'll do it right here. Let's put in our Y value. Let's put in our X value. And really quickly, we're going to see that we solved for one of our variable right off the bat. See, I just plugged in for Y value, I plugged in 0. For the X value, I plugged in 0. What variable did we solve for here?
C.
C is 0. You see, each point that we assess, we're going to be able to include other information now that we know what C is, right? Now we go to this next point, which is going to be our 1, 2. And I'm going to go ahead and put in these values and watch what happens. 1 squared plus b times 1 plus, what should I put in for c?
I mean, you don't have to put anything. Like 0.
0. See what happens. You see how you find one part from one point. In the next assessment of the next point, you can use that information. Because this is all a system. We're finding a quadratic for the following points, the quadratic that fits all those points. So we solve this out. It doesn't look like it's going to work out great. But let's go ahead and still solve for A or B. Give me a letter.
A, B.
A.
Let's go with B. You corrected it quick. Solve in terms of B. Solve in terms of B. Minus A, minus A. 2 minus A is equal to B. Okay. We just found our B. What's going to happen? It's going to be like dominoes. I'm guessing that over here we'll find our A value. We find our A value, then we can plug into here, we got our B, and so on. That's going to happen often. So don't worry if you get here and you're like, that doesn't look right. It's because we can still find some information to find the actual value for B. Okay. So let's do the last point here. 8 is equal to A times 2 squared plus B times 2 plus 0. Go and solve this out. And now is the point to do what? Now is the point for doing what? There you go. So go and use what we found out about what we found out here. We know that B is equal to the 2A, so what I'm essentially doing is saying, well, I'm going to plug this in right there. See how we can do that? It's like a rule within a rule. And then you find the answer for that rule, and then you have the answer for that rule. Yeah? See where we're going? Now look at that equation. What one variable do we have to solve for? A. So we're going to get A. Okay, go ahead and get A. I'm confident in you guys doing that, so I'm going to go ahead and knock it out as well. Move that over. Combine those. Oh, look at that. Look at that. Now it's a dominoes, right? Now you have all the information. So now what can we do here? Hey. Now we're going to go ahead and plug in 2 minus 2 is equal to B. So B is 0. We have A, B, and C. Then we're going to plug it. We're going to plug it on in. Let's go after the lesson. That's perfect. All right, we have A, B, and C. Let's plug it in. Y is equal to 2x squared plus 0x plus 0. What can I just erase here? The zeros, right? The B and the C are going to be just gone. Because 0x plus 0, that's all 0. There we go. We found our quadratic. It's not so bad. You just have to be used to kind of finishing something incomplete here, finishing something semi-done, and then you'll find another clue. Okay. All right. For this one, I'm going to use my notes to do some of these calculations. All right. This is the last one here. All right. Current Sacramento population is 501,000 people. So 2019, that's what it is. It's projected to grow to 2.2 million by 2060. Find an exponential growth equation for the population. Okay. So let's go ahead and fill in this table, which is going to be helpful for us to do. We're relating it to the year 2000 because we know that we want to express the current Sacramento population as a growth formula. And if we say that it starts in 2019, we can't show growth. If we say, show me right now a growth formula for an amount right now, you have nothing to compare it to. So we have to start by just comparing both of these values, both measurements, to 2000. So how many years has it been time since 2000 for our first? 19. How about our second? 60. What was the population in millions for now at 2019? 0.501. 2.2 million. So we have this data. No.
Oh.
I like that. That was it. I have all this space though. All this. I gotta use it now. It's fine. All right. We have two sets of data, so we're going to do two different equations. We're going to solve for what we can and then combine them. Again, this is all about clues here, bring it together. So the outcome from measurement 1 is 0.501 million. The initial, we don't know. The growth rate, we don't know. We know it was 19 years. Okay. Now I want you to solve that in terms of A. Solve that in terms of A. We're going to have A is equal to something. 1 second. 1 second, give you. And again, this is like where it's going to feel like that can't be what I'm looking for. Because I'm just isolating, getting in terms of A. The dominoes will all fall later. But I know what A is in terms, I know what the value in terms of A is. Do the same thing over here. See if you can set up the formula for what we have over here. We're going to go with outcome. I don't know my initial yet. I don't know my growth, but I know it took 60 years. Here's the deal. I know what A is. So what do you think now I'm going to do with this expression of A? Right there. Let's plug it in over there. It's all about finding clues from one to solve the other because this is a system. We're talking about the same city. Same system. Okay. So let's go ahead and do 2.2. We have 0.501 over b to the 19th times b to the 60th. So essentially we have that. And let's solve for these. Let's reduce those. Actually, I want you to go ahead and try to reduce that. And you're going to end up with 0.501 b to some power. I want you to find that power and maybe check with your neighbor after you get it. After. If you can't imagine it, imagine that I expanded those out. I wrote 60 B's on top. I wrote 19 B's on the bottom, and then what would I do with them? And then that should remind you, hopefully, about the exponent property, which we can do without writing it 60 times. Yeah. So essentially right now we're working on, if you're like, wait, what? We're just reducing this. And what do we do with the exponents when we are dividing? Subtract. B to the 41st? Yeah. Let's see what we have then. We have something. All right, let me double check my notes on this, because this is where we can actually work these values out. They've been done before. Let's go with this. All right, so now what we're going to do is, let's isolate B. Let's divide by 0.501. Just get rid of that. Gone. B to the 41st is equal to, and I'm just going to start throwing out some numbers here. We have 4.391. That's just this divided by this. And now, if this was 4.391 is equal to b squared, how would I get b by myself if this was b to the second power? Square root. If it was the fourth power, I'd take the fourth root, seventh power, seventh root, 41st power.
41st root.
Easy. Yeah, easier to think than say, yes. See ya, see ya. B is equal to, with this, that gives us 1.037. So all this you could do on a calculator. That might be a little trickier to do on the calculator. But how should I find what A is now? What should I do with this? B is equal to 1.037. What should I do with it? Plug it in right here. Okay. 0.501 over 1.037 to the 19th power. That's nice. It gives us a quarter. put it all together. Remember, the last thing that we want is an equation that works for both of these. So we're going to go back, look at our original, and put in A. We're going to put in B. We're going to put in T. And that's our answer. It's all about seeing that you start the problem out, you find a little bit with one step, and then it kind of dominoes. It all will fit into the others. And just get a little comfortable with, not going all the way. We end up right here, we're like, that can't be correct. You're going to end up in that situation a bunch with these problems. Okay. Thumbs up, sideways, down. How do we feel? We feeling? Okay, we got to do some of these. Okay. The first problem I'll let you know on the classwork is a problem like number 2, except there's only 2 points. So when there's 2 points, what kind of equation should I use? Kanemoto, get those tests back to me by Thursday if you took it. And that's it. All right. Goodbye.